Hi everybody, welcome to another video in the Swift Math section 10.2, graph terminology and special type of graphs. On this section we have a little more calculation in the sample than the previous one, but still there will be a lot of terminology. So basic terminology, two vertices U and V in an undirected graph G are called adjacent or neighbors in G if there is an edge connect U and V together. Such an edge E is called incident with the vertices E, U and V, and E is said to be connect U and V. Right, so not much. Right. The set of all the neighbors of the vertex V denoted by n of V, called that the neighborhood. Right. So degree of the vertex is in an undirected graph is the number of edges incident with it, meaning the number of edge connecting it. The degree, except for the loop, the vertex contribute to. Of course, if the loop like this, they consider two of them, one on each side. And the degree of the knot is denoted by degree of a knot. So here's some example. What are the degrees and neighborhood of the vertices of the graph G and H? Right here for A. Degree of A. There are two edge connect to it too. And neighborhood of A. That would be the set of point B and F. Right. Degree of B. 1, 2, 3, and 4. Neighborhood of B is A, F, C, that is E, sorry, and C. Now C, 1, 2, 3, and 4. N of C, B, F, E, and D. Now degree of D, there's only one edge to it, and the neighborhood of D is C. E will be 1, 2, and 3. Neighborhood of E will be C, B, and F. Degree of F, 1, 2, 3, and 4. Neighborhood of F, A, B, C, and E. And degree of G, no edge connect to it, so that will be 0. And the neighborhood of it will be an empty set. Right. So it's simple enough, very straightforward too. Now we're going on this graph. Degree of A, 1, 2, 3, and 4. Neighborhood of A, E, D, and B. Degree of B, one, 2, 3, and 4, and itself. Right. 1, 2, 3, 4. 1, 2, 3, and 4, 5, 6. And neighborhood of B will be A, E, D, C, and B. Degree of C, 1. Only connect to B. Degree of D, 1, 2, 3, 4, and 5. Neighborhood of D, 1, E, B, and A. Degree of E, 1, 2, 3, 4, 5, 6. Neighborhood of E, A, B, and D. Oh, D does not connect to D, sorry. D is A, E, and B. Sorry. Right. Next we have this handshake theorem. Right. So we say that if G is a graph is an undirected graph with m edges, then 2 times the edges is equal to the total on degrees. Right. So here is an example. How many edges are there in the graph with 10 vertices of degree 6? So the number of vertices, and then so there will be, we have 2 times m is equal 10 vertices, degree 6 each. So that means m is equal to 30. And then we just apply for the next one. 2 times the number of edges is equal to 5 vertices times degree of 3. So 2m equal to 15. So m equal to 7.5, which is not possible. Right. So an undergrad graph has an even number of vertices of odd degree. So that's just what comes from the previous example. Right. The graded graph, we do the same thing, but this time the graph will have a direction. So in that case, we have the terminal and initial. Initial is the one where it starts, the terminal is where it ends. Right. Then U is initial point and adjacent to V. And V is adjacent to U. Right. So let's look at one example. After that, we define the in degree, the degree that coming in, and degree that coming out. Degree that coming in is minus, degree that coming out is a plus. Right. So here's an example. Just write what we have for degree. A. How many coming in? Minus is in. So 1, 2, degree of A minus 2. B 1, 2. One, 2. 1, 2, and 3. Sorry. Degree D 1, 2, and degree of E and F 1, 2, and 3. Degree of F, isolated point, therefore degree coming in 0. Now we'll do the same thing but for the plus coming out. One, 2, and 3, and 4. Coming out 1, C. Coming out 1, 2. One, 2, E, 1, 2, 3, degree of F, again isolated, not degree of 0. Right, next we have let G be the graph of the vertices and edges. The number of edge is equal to the number of negative, the total number of degree coming in equal to the total of the number of degree coming out. Right, now some more terminology. We have the complete graphs. Complete graph is a simple graph that contains exactly one edge to each. So those are simple. One edge between each pair of distinct vertices. So every point have to connect to every other point, and exactly once. A cycle is where we're connecting in cycle. Right. C1. We cannot have that. C2. So C3. 3 0, 3H, C4. So just in the circle. C5, and then so on. A wheel is pretty much we have a circle, and then the point in the center connect to everything. That's a wheel. Then the n-dimensional have a cube, so we have just like a cube here. Yeah, there's still a lot of introduction in this section. Next, bipartite graph. Right, a simple graph tree is bipartite if V can be partitioned into two disjoint V1, V2, such that every edge connect a vertex V1 to V2. In other words, there are no edges connect two vertices in V1 and V2. So pretty much they have two set of things, like the one on top, the one at bottom here. It's completely separate. Right. So for example, if we look at this one, right, I have to check, look in color much better. If we look at this vertices and the other vertices, those two points do not connect to each other, so I have two different sets, and each one of them connect to every other one. This one, 1, 2, actually doesn't have to be every other one, but it only connect to the other side. They do connect to themselves, they connect to other sides. This one connect to other side. Yeah, check. This one cannot. We cannot do the same thing. Right. I see how that works. So that C6 is bipartite. C6, pretty much a hexagon. Right. Now, if we look at this one, of course, those 3 points do not connect to each other, but each point connect to the other point on the other set. Yep, so we have like two group of points. Every point on this side connect to the point on the other side. They don't connect to themselves, connect to other side. So that C3 is not bipartite. We cannot do that. We cannot separate two sets because when we separate, there have to be 2 points connect to themselves. So it is not, by definition, it's not bipartite. Complete bipartite is something like this, where we have into 2 sets of sides such that an edge from every vertex in V1 to every vertex V2. So 1 point on this side connect to every point on the other side. So that is the type, some type of common graphs. Like I said, the previous this section and previous section, we have a lot of terminology of graphs. And with that, we stop section 10.2 here. Thank you for watching, and see you in another video in the Squid Man.